Okay, well, we got the 3-jaw bolted down to the table of the mill. Just a couple of quick clamps with those rocker type clamps. These are nice because they got the brass on them. You don't damage anything. I've got a cushion underneath the chuck. I've just got a piece of 1/8 inch aluminum plate to act as kind of a cushion so I don't scar up my chuck or the table. So we put that in, and then we came back and we put our part in here. I've got 3 little aluminum angles cushioning the part. Remember, the part's still soft, so I could very easily mar these surfaces. Got some parallels in here, dropped it down on the parallels, tightened it up in the chuck. Last thing we did was get it centered here and get it indicated over that point. So we're center of the point. All that's left to do is roll the head of the machine over 30 degrees and pop our hole. So let me get that tilted and I'll bring you back. Okay, well, we got our head tilted. So you double check, make sure we're on center here. Now let me shut this down. The next thing we need to do is make sure that I'm putting this spot in the hole where I want it. And I want it 1.5 inches from the tip. And you can see I've got here, this is my new sliding protractor. I got it set on 60 degrees and I'm 1.5 inches right there. So this is just going to drop on to that point, and wherever that needle intersects here, that's where we're going to do the hole. So we're 90 degrees from this surface, and we're ready to cut. So all I gotta do is kind of back out the quill a little bit and lift the table, and we're going to be ready to go. I got to turn the spindle back on, make sure that thing's spinning true. Alright, we're all set up with an end mill. That's just a plain old high-speed steel going into 01. High-speed steel usually loses just a dab of anchor lube. We're just spotting it on the bottom, so we're not applying that much cutting pressure. After I fire up, I'm going to be going down to about 900 RPM. All we're doing is going to take this out to full diameter, out on the edges, just to give us a flat spot for that shoulder bolt to seat into. And we are there. Okay. Okay, so we're going to start off with a little spotting drill, just to make us a little clean starting point. That'll get us going. And now I've got a 5/16, which is the tap size for a 3/8. That's coming up next. Let it zero my DRO. I'm going to go down an inch. I'm only tapping 3/4, so. You get a countersink. I'm going to put a nice heavy chamfer on that. Monitor my progress with the DRO. I watch how far that tap's diving. All right. Okay. Got a pretty deep thread there. I'm going to run a bottoming tap in it and just get, that was just a gun tap, so I know I got a load of chips down the hole. I'm going to get that hole cleaned out and run a bottoming tap in there and get threads all the way down to the bottom. All I need is a 1/2 inch worth of threads, so for a shoulder bolt. So I think we're in pretty good shape. But I'm going to leave the setup here until I get that thing threaded all the way to the bottom. I'll probably take the chuck out of my way. Oh yeah, it's a good looking thread. I don't think I need to do anything to it. All right, well that's the drilling and tapping of the center. It's ready to go to heat treat. Okay, well our hole's done. We've got it in the same place as the old one. Here's my old one here. So that's how that shoulder bolt threaded into that one. Believe it or not, this one used to look just like this one did before I started carving it away. So there's the name of that tune there. Alright, so we got our logo in there. Got my logo there, got my pin there. I'm ready to take this thing to heat treat and make her red hot. Quench it in some diesel oil. Alright. Well, I'll tell you, that was an awful lot of work to go through just to drill and tap one hole. And now I got to put it all back. Awesome. Hey guys, welcome back. And I was doing some squares. I got those in the tempering oven now, so they're cooking at 400 and tempering down. And I thought as long as the other little oven's on temp, I'd go ahead and get this fella done here. And what I'm going to do is I'm just going to use a piece of threaded rod in the hole, and I'm going to put a little anti-seize down the hole and just leave it in there so I got something to get a hold of it with. And I've taken this piece of all thread and ran a button die over it to actually undersize the threads to make sure I don't get any seizure problems or anything at those drastic temperatures. But we're going to put a little bit of anti-seize on the threads, screw it in, not all the way down to the bottom and certainly not tight, but as you can see I've got a very sloppy thread there, which is what I wanted. So we're going to leave that kind of loose and get this thing prepped to go in. We've got kind of a buffer in here now that I use for doing squares, so I'm going to get all that out of there. It's just a piece of 4-inch square tube I use. That fellow there. And I've got some blocks in here that can come out. Just a little bit of refractory element. And now we should be able to put our part in. Hopefully the door is going to fit with that threaded rod on there. It's just a tiny little oven. Yeah, it's going to be fine. Okay, so we're going to set a timer on that for about an hour. It's going to take a while to saturate that thing all the way through. And she's ramping up now, but that part's going to take a while to soak through. So let's bring it back and we'll dunk it in some oil. Okay, does anyone want to see what this little piglet looks like? It's been cooking in there for 45 minutes now. It's up on temp, and I think we're ready to drop it in some oil. So let's take a look at this guy. Oh yeah, she's bright red. There she is, going in the oil. It'll take a while to cool that thing down. Okay, next up it goes to tempering as well. Look at that rod come right out of there. That's a beautiful thing. Nice. Keep my oven on cool down here. It's a bad idea to shut a hot oven down. Just turn the thermostat down, let it run. The cooling fan will continue to run, and the oven will bring itself down to temperature. Leave the door open, let it cool off. I just set the thermostat for 300, but that's plenty to let it cool down for about 15 minutes before you actually do a shutdown. If you just do a hot shutdown, the oven can basically cook itself inside. So, time for a temper. I think we'll fit in there pretty good. Put our grab handle back in here real quick. That thing for an hour. Done. Okay, good morning guys. It's the next day and we need to get our stuff out of here. We had a timer on it. If you're gonna get a little tempering oven, make sure it's got a timer. You can set it for an hour and close up the shop and the stuff will be done and tempered by the time you get back the next day. Get this oily mess out of here. Cookie sheets are a wonderful thing. Our little piece we made for a grab handle can go to the, hey, look at that, go to the scrap bin. Anyways, metal cookie sheets, either steel or aluminum, are handy for hardening. Gives you somewhere to set stuff on, move parts around the shop, whatever. So all our hardened stuff can come out of there and into here. The hardening bench is always such a mess. Here's our center. All the scale and everything comes off of it. But our center's hardened now, and I'm certain it's moved to a degree. But we want to see how hard it is. We're going to take it over to the bench and put a hardness tester on it. We'll probably check the shank here, and then we'll check the point and see how hard it got. Okay, so we're going to test hardness. I've got it in a V block. I'm using a portable hardness tester by PTC Instruments. It measures Rockwell C-scale. These are the two components of the system. Comes in a nice case, and it uses a mag light with a little fiber optic cable coming down to your workpiece there. And all we're going to do first, this is very much like a snap center, but instead of a center, we've got just a little carbide ball there, and we're going to make a punch mark in it. And now we're going to measure it. Inside we've got a reticle, so it's direct reading. And we just come in here and find our crater, and we can directly measure hardness. and I'm getting a reading of 55 Rockwell. So we're measuring the outside. This reticle goes from 20 to 65 Rockwell. So I'm going to check it in a couple more places. You know, spot check it, make sure it got hard everywhere, but that's plenty hard for what this thing is. And it's a lot harder than the material was when we first started out. I think 01 tool steel in its annealed form is in the high 30s. So we did a substantial hardening on it, and that's plenty hard for me. I don't want it glass hard. I certainly don't want it slipping in the spindle, and I really don't want it harder than the spindle. The spindle is a hardened spindle. So I'm pretty happy with that. We're ready to grind.